Hey everyone, I'm TJB Chris. Welcome back to the channel and welcome to part 3 in my quest for 8 megabytes of RAM on the TRS-80 Model 16B. And today I've already removed the boards from the machine, so we have our usual complement of 68,000 cards plus our new stars of the show. So we'll go through the boards real quick. This is the 68,000 6 megahertz short CPU card, and then I have 2 of the 68,000 memory boards. Its associated ribbon cable and bagel parts, ribbon cables. The current memory configuration in this is 512K of RAM, which is what I've had for the duration. So we're now going to try and upgrade this to 8 megs, but we're going to do it in 2 phases. So the first thing we're going to do is we're going to try and run the SRAM board directly with the CPU card without the MMU. Why would I do that? Because I want to see, with as few changes as possible, if the board even works. If it does work, I think I should get at least a megabyte of memory out of it. And God help me, I may just prove myself wrong in a few minutes, but the goal here is to see if I see the standard amount of memory if I wire this up correctly. If that works, the next step will then be to install the MMU board and its upgraded PAL. This PAL here will go into U36. And if you remember from my last video, I socketed this and I soldered the jump to the socket in the hopes of having to avoid breaking out the soldering iron every time I change the PAL. But if it proves unreliable, it'll come out. So let's do it. Let's plug in the 68,000 card and the memory board and see if it works. Alright, welcome back to the messy little mess of my 16B here. I didn't want to take all the stuff out, so we just kind of left it. So here's what we have. On the board here, on the SRAM board, you can see I've attached a jumper. TP1 here has to go to pin 33 of U2 on the CPU card, and this ribbon cable has to attach. Now this is the shortest one I had, so what I'm going to do is kind of start to slide this in, and then we're going to turn this around and attach. And that's just, this is the longest cable I had floating around. I've got to get more 50-pin IDC ends. So with that in mind, let's get this installed. Alright, we're powering up. Boot prompt, smoke check. No smoke. 68K. Woo, okay. Connection check. Alright. We've reseated. Recheck. Now, I might have to reorient those boards. The orientation may matter. Yeah, it does not find a 68K. Oh, well, that's Fred. Alright, that's Fred. Let's see if it's happier now. Alright. Well, it's been a few days, and I've taken a little bit of time to take a look at this, but I haven't had a whole lot. But while I was waiting, and while I was noodling on it, doing a little bit of basic troubleshooting, making sure I didn't miss anything stupid and obvious, one of the designers of the card reached out to me and indicated he might have an updated PAL for me for the U36 PAL on the 68,000 CPU card. So I put that PAL in, and now it behaves a little differently. So what it does now is when you hit enter at the XENIX boot prompt, instead of saying there's no 68K CPU, which apparently appears whether there's missing memory or missing CPU, now it tells you there's a specific 68,000 CPU memory error is what it says. So it's still blowing up, but it at least recognizes the memory. So I popped on the diagnostic, and I'm just going to rerun it here so you can see what we've got. And I'll take a look at and show you what the symptom is now. And then I'm going to try and figure out what that's about. So the first thing is the bus arbitration test does pass. So now we're going to do the quick memory test, single. And you can see now it sees I had the board configured for 1 meg because I don't have the MMU in there yet. It sees that the top of RAM is 5 foxtrots, 5 FF. But what it's going to do is, instead of getting a pass, it's going to start listing what's wrong, because things aren't quite right, but it's an interesting little pattern that I'm going to have to follow up on. So we'll just let this go. It doesn't usually take too terribly long, and there we are. Okay. So what you end up with, I don't know how well this is visible. Let's just zoom that in a tad. So what's wrong here, or at least what I'm seeing is memory is being written and then read, but the numbers, the values I'm getting back are exactly 1 off. So if I write 3, I get 4. And if I let that roll, this happens all the way up through the series. And basically what this test does is for every address, it just keeps cycling through the different values, you know, incrementing them. And when it gets to FF, it starts back at 0. So when it gets to FF, the value wrote will be FF and the value read will be 0, 1. And we're just about there. There we are. So wrote FF, read 0, 1. So, and same thing here, F3, F4. So clearly I have something wrong here, but I'm not exactly sure just what yet. So the plus side is we do have memory. It can identify the top of RAM. It also is storing most of what I need, but something is off there. And so the very first thing I'm going to do is make sure that my socket connection for U36 is good. And quite frankly, now that I know that the PAL is good, I may just take the socket out and solder the bodge wire for that jump we did in the last video right to the pin 5 of that U36 and get the socket out of the way. This will eliminate any future problems that could come with it. And honestly, it's 1 wire I have to desolder. So anyway, let's take a look at that and remove the socket and see what happens. So here's what we're looking at. I was talking about U36 earlier. You can see that. This is U36, and I did this sandwichy socket thing where I stuck a socket in and then put U36 there, and I soldered the jump onto the socket. But some folks have had better luck than others with this, and rather than make it an issue myself, I'm going to pull it, because it's not like it's, you know, the chip will just go right into its socket, and I'll just have to solder this jump to pin 5 of this GAL. So that is what we're going to do right now. We're going to warm up the iron, and we're going to get our various soldering bits out, and we're going to do this. Okay, so we have the GAL is now directly in the original socket on the board. Pin 5 is bent up and soldered over to its jumped location. It's not touching anything. So this should cover us in terms of eliminating this smaller socket as part of the problem. So people have had mixed luck with this, and quite frankly, now that I know the GAL is good, I'm not going to mess with it, and unsoldering this jump is not that difficult. All right, let's put this in the machine and see if it behaves any better. All right, we're back. By that I mean I've stood up. Did I get that? I did not. There we go. All right. It's still fun to use this disk drive. I don't care what anyone says. All right, let's boot the Diagnostics up, and we'll see what it says. There's a bit of an extended diagnostic that's been adapted to the larger memory sizes that I can also try out that might give me a little more insight, but for now, we're just going to stick with a basic diagnostic and hope we get somewhere. I don't expect this is going to make any difference, by the way. I'm only doing this to eliminate it. A very low-hanging fruit in terms of variables. All right, bus arbitration, passes again. I always check that because sometimes if you screw it up, you can tell that it's not going to work if that fails. All right, let's do the quick test. And we are still getting the same result, which is expected. Okay, so I've at least eliminated the socket. So now I'm going to have to start taking a look and seeing what's where. I think the very first thing I want to do is make sure that my work on the surface mount SRAM chip is legit, that I don't have any bridges that I'm not thinking about or any pins that are not in contact. So that's going to be my next bit. I'm not going to make you suffer through watching me try and poke at it with a meter, but that's what I'm going to do. I'm also going to double check solder joints, make sure I didn't miss any other obvious components and things like that. But that is where we are. I wanted to give you the mid-update, and then hopefully we get this to the point where it works, and then we'll move on to the MMU. But, all right, more to come. All right, we're back with some progress. I spent some time doing a little troubleshooting, and it was just kind of here and there, so I apologize for not putting it on camera, but at the same time, you didn't get to watch me play with a voltmeter, I don't think you're missing much. Anyway, we have some progress. Let's take a look. As you last remember, 5 seconds ago, we were getting a memory error, but it was actually detecting the top of RAM. So now, check out bus arbitration. We pass again as usual. Now let's do a quick 68,000 memory test, and we'll just do the single test. I'll show you what it's doing now. Play the Jeopardy music, but I get a copyright strike. Let's cut that out. Hey, we have a pass. That's what's happening. We're passing now. So I have the SRAM card configured for 1 meg of memory. Only one of the 8 banks is available. And it passes. It passes the basic memory test. So this is a quick test. It's not long. It's not comprehensive. But what actually ended up happening was a little stupid. So I'll get into that. But while we're here, I'm going to just break out of this. We're going to pop the diskette out. This still doesn't get old. We're going to hit the reset button. And we're going to give XENIX a boot and hope the Fred doesn't give me a hard time today. Looks like it's going to work. There we are. And look at that. 160K plus 864K, that's 1024K. So we've got XENIX showing the proper amount of memory in the machine. So right now we have 1 meg, and that is just with the SRAM card that's in the machine connected to the 68,000 CPU board with the updated PAL and everything. So what happened here? What the hell went wrong? Having gotten the PAL update, I decided that it was time to start tracking my way back from the 68,000 board to the SRAM card and work my way in from the outside. So essentially come in through the expansion port. You can see I've got my memory enable here wire on pin 33 of U2. This is ribbon cable here I made. So what I did was I put the SRAM card with my ribbon cable connected on the bench over here, and using my meter I went through and probed each pin on the cable and each corresponding land on the bottom of the header. So each solder joint on the bottom of the header. And this way I could show that the pins on both ends of the cable were good, my crimp job was good, that the header itself was okay, and that the solder joints were okay. And if I got any that didn't work out, I could isolate it. So what ended up happening was I got to pin 38, and no matter what I did, I couldn't get a read off of it. So I took the cable off of the SRAM board and connected the meter directly to both sides of the cable, and pin 38 checked out. So now I'm like, well, what the hell? So we certainly have a connection problem, probably a problem with the headers. Do I have a problem with the solder joint itself or with the header? So just for the sake of curiosity, because I didn't actually look at the stupid header first, I reflowed the joint and tried it again, and the meter still didn't want to read. So all the surrounding pins were fine. And then as I got looking closely at the header, I saw this. That's a pin missing. I'm pretty sure that pin's been missing the entire friggin' time, and dummy here didn't notice it. The irony here is the SRAM board, I think, is the hardest part of this build because of that 48-pin TSOP, the SRAM chip. I got that right the first time. The hardest part of the board I got right, but the thing I've done a million times, these headers, I apparently, in my zeal, wasn't paying close enough attention. Now that it's replaced, lo and behold, it works. So where does that leave us with the 16B? Well, we have one of the 8 megs working, the SRAM board is functioning, and the PAL and wiring job I did for the burst mode upgrade that we've already seen is working. So now next is to do the MMU. So that's going to be it for this video. In the next video, we're going to do the MMU, and there's another set of modifications and jumps that has to be done on the 68,000 CPU board in order to make it compatible with an MMU and add-on MMU. So that has to be done. I have that information, the instructions for that, so we're going to get right to that. And then we'll put the MMU into the socket and we will test it out. So conceivably, part 4, I think it will be the last part if this works. And I'm really glad I did this one step at a time. If I tried to boil the ocean, this would have been just a gut-wrenching, terrible experience. If I just built it all and put it together, it wouldn't have worked. So this has been just awesome, and you can see the machine's happy here. I mean, I'm in single user mode, and caps lock's not going to work. so there's not going to be much going on, but that's it. The machine is happy, and I do have a lot of comprehensive diagnostics in front of me, but I'm not going to put those all on camera. I want to run through the larger memory diagnostics, let it run for a few hours, really kind of try and burn the machine in and make sure we're good, but initial indications are positive, and I'm very happy about that. So this is a very exciting time, and this machine is probably 70% of the way to 8 megs. What I have to do next isn't very difficult. The MMU board wasn't tough to build. So anyway, that's enough rambling, and that's the end of part 3, the quest for 8 megs on the Model 16B. Thank you for joining me. Join me once again for part 4, where hopefully this machine actually has not 2, not 4, not 6, but 8 megabytes of memory. Until then, grab your favorite scotch and stay classy.